Hello everyone, my name is Samuel Esung and welcome back to my YouTube channel. This is the next video in our DevOps playlist, and today we'll be looking at Docker as a containerization tool. This video is very practical and it is also very intentional. In our last video, we saw why containerization was necessary, and we also saw the evolution from physical servers to virtual machines and to containers. So we also spent time understanding what a container is. We talked about processes, kernel isolation, namespaces, and C groups. So today we are not redefining containers again. So today we are answering a different question, which is how do we actually build, package, and run a container? How do we build, package, and run a container? And this is where Docker as a tool comes in. So what exactly is Docker? Now, Docker is a containerization toolchain. It provides a complete workflow for building container images, it also provides a workflow for storing container images. It also provides a workflow for distributing images, and lastly, running containers. So Docker is not the container itself. Docker is the platform that makes containers easy to build and use. So conceptually, a container is a kernel isolated process. So Docker is a tool that allows you to describe that process environment, package it, and run it consistently. Now let us look at why Docker became very popular. So before Docker, using containers required deep kernel and system knowledge. So Docker introduced a very simple build file, which is known as the Docker file, a very simple command line interface, and a predictable workflow. So developers and DevOps engineers could adopt containers without needing to be kernel experts. Secondly, Docker introduced a standardized image format. So understand that images are built in layers. All right. So this means that builds are faster, caching is very possible, and distribution is more efficient. So this was a major innovation for real pipelines. Now, Docker also introduced a natural way to push images, pull images, and also share images across teams. So this solved the problem of distributing application artifacts at scale. Now, another thing that makes Docker very exciting is the fact that Docker has a very strong ecosystem. So there are a lot of systems that integrate Docker as a tool. Now, Once Docker became very popular, the ecosystem followed. CI systems integrated Docker, cloud platforms integrated Docker, orchestration platforms also integrated Docker. So Docker became the default interface to containers. Now, let us also look at, or let us see if Docker is the only containerization tool. Docker is not the only containerization tool. Now, this is very important, so you do not think that container equals Docker. No. There are some other important tools and runtime like containerd. So containerd is also a lightweight container runtime. Now containerd is what actually runs containers under the hood in many platforms today. Now take a look at Kubernetes for example. So Kubernetes commonly use containerd. Now we also have CRI-O. So CRI-O is another container runtime built specifically for Kubernetes. So it also focuses on simplicity, Kubernetes integration, and minimal interface. Now we also have a very popular tool known as Podman. So Podman is a Docker compatible container engine. So it allows you to build images, run containers, but it is a daemonless and more security focused. So understand that many organizations today use Podman instead of Docker engine on servers. So now that I have exposed you to some other container engines, it is safe to say that Docker is one popular container tool. So, but the container ecosystem is larger than Docker. Now, let us move to Docker installation. So on Windows, what you install is known as Docker Desktop. This is a link to install Docker. So I'm going to share this link in the video description. All right. So you can select the environment you want to install Docker on Windows, on Mac, on Linux, and download Docker Desktop for Windows. Choose your preferred architecture and download Docker. So understand that Docker Desktop uses virtualization. So what happens is that it runs a Linux machine internally because containers rely on Linux kernel features. All right. So what really happens is that on Windows, you have the Linux virtual machine, then Docker engine inside that virtual machine. So this is very important to understand. So if you are using Docker on Windows and if it is your first time, you must understand that you will need to enable WSL. WSL2. So WSL is a Windows subsystem for Linux. So Docker Desktop integrates with WSL. So when you install Docker Desktop on Windows, you are not running containers directly on the Windows kernel. You are more like running them inside a Linux environment. So if your operating system is Mac OS, you can choose your installation environment on Mac, then follow the prompt and it gets easy. All right. So for Linux, these are the instructions for Linux. Also, choose your distribution and follow the prompt. Now, for you to install Docker, you must have at least 4 gig of RAM. This is the prerequisite. All right. So, and also if you are on Linux, you can simply do sudo apt install docker.io -y. So this is going to install Docker for you. All right. Then after installation of Docker, you will want to run Docker as a user. All right. So to do that, you simply do sudo user mode -ag. All right. Then Docker. Then what user are we adding to the Docker group? You can explicitly select a user, or you can use this to add all users to your Docker group. So now that we have Docker installed, let us look at the Docker architecture. So let us quickly look at what is running when you use Docker. So Docker has a client, and it also has a daemon. So the command you type is sent to the Docker daemon, like your Docker run, Docker build. These commands are sent to the Docker daemon. So the daemon is the component that builds images, pulls images, and also run containers. So the high-level architecture is that you talk to your terminal by writing commands. Then your terminal talks to the Docker daemon, and the daemon talks to the container runtime. So now that we understand the container architecture, let us now quickly look at the container or Docker lifecycle. So the Docker lifecycle simply explains the natural flow, or the natural flow of working with Docker. All right. So step 1 is you build. So you build an image from a Docker file. So after building, this is going to create what? A container image. All right. Now, the next in our life cycle is store. So you can store the image locally, or you can push this image to a remote repository. So remote repositories include Docker Hub, and since our DevOps is around AWS environment, then ECR. So ECR stands for Elastic Container Registry. Now, the next process in a Docker lifecycle is Docker pull. So what happens with Docker pull is that another machine can pull that image. Then we now have the run. So when you do Docker run, a container is created from that image. All right. Then the another process in our life cycle is stop and remove. So containers can be stopped and containers can be removed, but your images still remain. So now, always remember that an image is a template. All right. So container is the running instance of that template. So now that we understand what happens with the Docker lifecycle, let us see some common commands with Docker. So we are going to go through the most important commands, and the very first command is Docker pull. So what does Docker pull do? Docker pull downloads an image from a registry. It can be from ECR, it can be from Docker Hub. Now, the next command is Docker images. So this command lists all images on your local machine. So the next command is Docker run. So Docker run creates a container and starts it. So this combines creating a container and starting that container. So the next command we are going to look at is Docker PS. So Docker PS simply shows or lists running containers. Now the next command we also see is Docker PS, but we'll combine it with the -a flag. So what this guy does is to show all containers, even with the stopped ones. And the next command we are going to see is Docker stop. What does Docker stop do? Docker stop simply stops a container from running. Now the next command we are also going to see is Docker remove, Docker rm. So Docker rm simply removes a container. Docker stop stops a container from running. Docker rm removes a container. The next command we are also going to see is Docker rmi. What does Docker rmi does? Docker rmi removes an image. Okay. Then the next command you will likely use is Docker logs. So Docker logs simply show the logs of a container. All right. Now we can also see Docker exec. What does Docker exec do? Docker exec allows you to run commands in a container. So Docker exec allows you to run commands in a running container. Now the last command we are going to look at is Docker build. What does Docker build do? Docker build builds an image from a Docker file. All right. So these commands forms your daily workflow with images and containers. So now that we have seen the life cycle, we've also seen the commands we will always use. Now it is now time for us to containerize a simple static website. All right. So I have a very simple static website, a very simple HTML static website here. All right. So let us see how we can containerize this website. So this is a very simple example, and it is just an HTML file. So the first thing we are going to do is what? To create a Docker file. And to create a Docker file, make sure that Docker file is in the root of your working directory or the root of your current working directory. And our current working directory is what? The demo folder. So I'll create a Docker file on this root. And to create a Docker file, you simply type Docker file with capital D. All right. So we are going to go through this Docker file one by one, or line by line rather. So the first thing we are going to use is a base image. And to use a base image, I will do from Nginx Alpine. Now, this is the base image. So this tells Docker, start from an existing image that already contains Nginx. All right. So Alpine is a variant of a very small Linux distribution. So Alpine is going to give us a very minimal operating system. And in this operating system, Nginx is going to be installed. So this is going to make our container very lightweight. So the first line is extremely important because every image is built on top of another image, except a scratch image. All right. So the next line in a Docker file is going to copy. Will be for us to copy I'm going to copy the index.html file we have here to /user/share/nginx/html. So what is happening here is that we are placing our HTML file exactly where Nginx expects it. Now you would want to ask, assuming we have other files listed here, should we single out only index.html? The answer is no. What you do is, you can simply do copy. So you copy everything on this root folder into user/share/nginx/html. All right. So these lines copy our website file from our local directory into the image. So this destination part is very important because Nginx by default serves static files from user/share/nginx/html. So we are simply placing our HTML file exactly where nginx expects it. So the syntax is simply copy source to destination. Copy the source, then to destination. So this is the syntax. All right. So in our next line, we can expose port 80. All right. So this line does not affect the functionality of our image. What this line does is to simply document that this container listens on port 80. It does not actually publish the port. It is more like a metadata. So we are going to do the real port mapping when we do Docker run. All right. So, but for now, just understand that this line only documents this port. So our next line, we are going to define the default command for the container. So we are going to use cmd nginx-g daemon of. So this particular line is what runs when the container starts. So -g daemon of is simply telling the container to run nginx in the foreground. And the reason is because containers must have a foreground process. So if the main process exits, the container stops. So CMD is extremely important. So without it, the container would immediately exit. It starts and exits immediately. So this is what our full Docker file looks like. The base image, then we copy our website into nginx web roots, then we expose ports and run nginx. So this is all. This is very small and very portable. So the next thing will be for us to build our image. So I'll come to view, then bring out a terminal. So to build our image, we simply do docker build -t. Now the -t flags assigns a name and a tag to the image. All right. So -t, then the name of this image, I will call it my static site. And the next argument will be dot. So the dot is more like, the dot is simply a build context. All right. The dot is a build context. So the dot means send the current directory to Docker as the build context. So Docker, because Docker can only access files inside the build context. So this is very important for security and performance. So if we hit enter, Docker is going to read the Docker file, pull the base image if needed, execute instruction, and catch each layer. So each line in the Docker file becomes a layer, and this is very important for build performance. Now that we have our image, all right, so permit me to clear this out. Now, if I do Docker image, Docker images, then this is the image we just built, my static site. And what is the size of this image? 62.1 MB. It was created 26 minutes ago, 26 seconds ago, and the tag is latest. So now this is just a template. Now let us run this image. I'll clear this out. I'll copy the name of my image. Now to run this image as a container, we will do docker run -d. -d simply runs the container in a detached mode. All right. Then -p. -p is we are using -p for port mapping. So it's simply telling Docker to publish this port. All right. So the very first port is the host port, which is my local machine, your virtual machine, your physical server. All right. The host port. I will say, 80. So what this means is that the left side is the host port and the right side is the container port. 80 is the container port, 80 is the host port. So we are simply mapping our host port to the port in the container. All right. So now the next argument will be our container image. Our image name. And the image name is what? My static file. So if I hit enter, I can see that my container has been created and is running. So to check if your container is running, you can simply do docker ps. So you can see that I have one container running. This is my container ID, and this is the image. All right. And it was created 17 seconds ago. So how do I access my container? Since this is a local machine and I mapped 80 to the container port, so I'm going to access this from http /localhost and the port is what? 80. So my request goes to the containers nginx on 80. So if I hit enter, this is my static file. So how does traffic flows? Let us see how traffic flows. So we did docker run -d -p 80 my static site. So my browser is the host machine. So traffic flow from my host machine to the Docker port mapping, then the container network namespace, then the nginx process. So this directly connects back to what we learned about containers being isolated processes. All right. So we have our container running and we can access it from the browser. So let us clean up. To stop the container, I will simply do docker stop . I'll copy the container ID . All right. And hit enter. So my container has been stopped. So if I do docker ps again, I should not see any container running. So there is no container running. But if I do Docker ps-a, I should see that I have a container that was stopped 2 minutes ago, or it was created 2 minutes ago rather, and it exited 19 seconds ago. All right. So this is a very small example. Now, even after stopping our container, our Docker image still remains. Sorry, Docker images. Our Docker image still remains. Now, this example may look very small, but it demonstrates the full container workflow. We built, we packaged, we ran the container, we expose ports, and we deliver an application. So the same pattern applies to APIs, background workers, front-end applications, and even complex systems. Now, in our previous video, we talked about deploying applications with virtual machines. Now, if you want to connect this to our previous workflow, all right, so instead of us deploying code to servers, you now deploy images. Instead of configuring runtime environment on servers, all right, what do? You bake them into images. Instead of debugging server state, you can rebuild an image and even redeploy. So this is the operational shift containers introduced. To end this video, understand that Docker is a containerization platform. It allows you to build, distribute, and run containers. All right. So in the next video, we will go deeper and we'll also look at multi-build stages, then we'll also look at image optimization and security best practices. So thank you so much for staying up to this time, and please, if you are yet to subscribe to my channel, like this video and share this video with your friends. Thank you for watching, and I will see you in the next video.